All right, so we're continuing on with section 6.1, and we're going to continue on with the remaining three objectives. Objective 4, multiply rational expressions. Objective 5, find reciprocals of rational expressions. And Objective 6, divide rational expressions. So here we are, Objective 4, multiply rational expressions. All right, so the first step here is to factor all numerators and denominators as completely as possible. We did that before in the previous objectives. In order to reduce these things, we got to factor them because we want to cancel out any common factors between the numerator and the denominator. And that's what we're talking about when we apply the fundamental property. We cancel out common factors. So then once we have applied the fundamental property, we multiply the remaining factors in the numerator and remaining factors in the denominator, and we leave it in typically what we're going to do is leave it in the factored form. And then just want to double check once you've done this to make sure that it's in lowest terms. So here we are. So the first thing we got to do here is we're going to multiply this. So remember when we're multiplying fractions, remember we just multiply the numerators times the numerator, right? And then we would multiply the denominator times the denominator if we were multiplying two fractions. So we're going to do something similar. Only remember it said to factor it first. Notice what we have here. We've got m squared minus 16. That's a case of special factoring because that is the difference of two squares there. So we're going to factor that. And so we use the difference of two squares formula here to factor m squared minus 16 into m plus 4 times m minus 4. Now notice what we have here. Now we can consider, when we're multiplying these, we can kind of consider this as one fraction bar. Since we have this m plus 4 in common here, we can cancel that out. So what we're left here is m minus 4 m over m plus 2, and this is in its lowest it is in lowest terms now. So objective 5, find reciprocals of rational expressions. And we remember what a reciprocal is. So like whenever you're back in those days in grade school when you would divide rational numbers, you use the reciprocal to divide them. Remember, you flip the one on the right and then multiply across. So we're going to do something similar to that with these expressions. And in addition, so we flip it, right? That's a reciprocal. You flip the numerator and the denominator to get a reciprocal. Another way to think of this is two rational expressions are reciprocals of each other if they have a product of 1. That's another way to think about it. So here it is. To find the reciprocal of a non-zero rational expression, interchange the numerator and denominator of the expression. I like to say flip it. Flip the numerator and denominator, but the best way to say it in correct terms would be to interchange the numerator and the denominator. So here we are. So we're going to use those reciprocals to divide rational expressions. So to divide rational expressions, you multiply the first expression, which is the dividend, by the reciprocal of the second expression, which is the divisor. So here what we have here. So notice we have a division symbol here. So first we got to rewrite this by interchanging the numerator and denominator of the divisor. And we've done that here. Notice we move 5 to the numerator, and we move 15p plus 6 to the denominator. Now we can factor this. We can factor this 15p plus 6 by taking out a 3. So we took out a 3 out of this 15p plus 6, and it became 5p plus 2. Now we have something in common between the numerator and the denominator. So we cancel that 5p plus 2 out. Now what we do is continue multiplying on out the two rational expressions that we had there. So we multiply them on out here, and we get 5 over 18 because 5 times 1, right, is 5. 6 times 3 is 18. So that's the procedure for dividing. So here we have another one. Now this gets a little bit into the next section, but anyway, what we do, we call this a complex fraction. It's got it's got two rational expressions separated by a fraction bar here. So that's the same thing as division. So the first thing we do is rewrite it as a division problem. Now we're going to create the reciprocal of the divisor, which is 4k minus 3 over 8k. And this is what we did here. We created the reciprocal of the divisor. So now, remember, we would multiply across here, but first thing we want to do is cancel out any like terms. Notice first thing, the notice here is that 8 and 40 have common factors in them. We can divide 40 by 8 and get 5, right? So those, and also notice that the k's cancel out. So the 8 and the 40 are going to cancel. It's not really going to cancel. What it's going to do is reduce to 8 over 40 is the same thing as 1/5. So the 8 goes to 1 and the 40 goes to 5. So what we've done there is reduce that fraction. Same thing as reducing the fraction 8 over 40. And then we get 1/5 there. So now we multiply the numerator and the denominators, right? We multiply the numerators times the numerator, denominators times the denominator, and we end up with this case right here. Now, whenever you go to enter into the MyMathLab, I think it will accept that if you go ahead and distribute the 5 here. But I think in our original guidance it said to leave the denominator in the factored form. So either one of these should be acceptable in MyMathLab. And then there's one more. It's another one, and since it has this additional fraction bar, we got two rational expressions separated by a fraction bar. We call this a complex fraction. We'll get into those in the next one. I just wanted to include this in this section because it kind of goes into the same idea of dividing rational expressions. So the first thing we do is write this as a division problem. Notice I just took the numerator divided by the denominator here. And remember, our next step here is to create the reciprocal of the divisor. So we move 7x to the numerator and x minus 4y to the denominator. One thing we want to notice about 12x minus 48y is that we can take out a greatest common factor here. Another thing we'll notice is that 7 and 28 will reduce 7 over 28. 7 goes into 28 4 times. So what we're going to do is deal with those things there and reduce this thing down. Let's see what we do. So the first thing we do is factor out a 12 out of this 12x minus 48y. Now notice we have something in common here. We have x minus 4y in common. So that'll cancel out. And then the 7 and 28. 7 over 28 will reduce to 1/4 because 28 divided by 7 is 4. So what we end up with here is 12 times x. And the 28 goes to 4, so we've got 12x over 4. Now this will reduce even further. We can divide 12 by 4, and we get 3x. So that is dividing rational expressions there.